All right, so old-fashioned chatbots are obviously lossy. They repeat themselves over and over again, and they're bland. Google Translate is not so obviously lossy until you test it with really difficult text, and then it fails. And there are easy ways of generating failure for Google Translate. So, and what's going on now is that by adding more and more parameters to the AI systems that we're building in creating language models, we're getting closer and closer to having created in the machine an more and more adequate simulation of the way language works outside the machine. But it's still lossy, as we will see. And so we don't need to deal with this. ChatGPT is a lossy paraphrase generator for text. That's the main thesis. And Jos will give a more elaborated thesis in his presentation. It's bland, generally speaking. It's great for creating summaries, modulo the problems which we will identify. It's bland. It gives you often too much output. It can't really give one-word answers. It always wants to tell you what it knows. But the most important problem is that it's full of errors. So I asked it this question a couple of days ago. So who is William Hogan? I originally asked it. Didn't know any William Hogan. Eventually, we got it to recognize the William Hogan, but it got the initial wrong. He thinks you're called William W. Hogan. He's not. So if we go through, so it thinks other false things. All of these are false things. So this is what's left. The career before Florida is missing because it got it all wrong. It thought it occurred in Alabama. In fact, it occurred in Pennsylvania. And this is typical. And I'll give you another example in a minute. So using ChatGPT is worthwhile for creating summaries of a certain sort, but you have to check for errors. But because there are so many errors, quite serious errors when it comes to research science, it's not useful for research at this stage. And the one question is whether it can ever be useful for research. So this is another example. I was doing research on biomedical ontology, so I asked him what are the principal publications in this field, and it invented a new journal. And I asked it what were the 10 most important papers, and it invented 7 papers. Each of them were vaguely resembling existing papers. They had overlapping authors, overlapping titles. They were all in this non-existent journal. And this is partly a product of the fact that ChatGPT wants to be helpful. So it's giving you all this information, which it thinks you will be happy about. All right, now one more example, and then I'll turn this over to Jobs. So a long, long time ago, I was working on the field of consumer health. In other words, trying to find adequate means of dealing scientifically with the way patients describe their health conditions. And so I was working with some linguists on creating something called Medical WordNet, which didn't really go anywhere. It was an interesting experiment. The paper is still cited because the idea, I think, is a good one. Now, the idea was that we would create a kind of standard patient vocabulary, which would make, I don't want to exaggerate here, but would make all the mistakes that patients make in their understanding of their problem and what the doctor can do. Now, mistake is wrong. Now, all the simplifications which are characteristic of non-experts. So it was a non-expert controlled vocabulary for health. That was the idea. And now, since we have ChatGPT, and since ChatGPT is so desirous of being friendly, I figured it could build a consumer health vocabulary. And now I wondered how I could set up a situation in which it would do that. and I came across something called Family Feud. Now, I guess you all know what Family Feud is. I didn't know what it was because I come from England, and we don't have anything like, or we didn't then have anything like this. So the idea of Family Feud is that you ask questions and you give answers which are not necessarily true, but which are typical of what ordinary people would answer. And so this is the question. Tell me something sharks are known to eat. And you have to say either fish or people, and then there are some small scale, low probability options which people can give. These are the two that one is searching for. So I tried it with ChatGPT, and it gave me this list. So really friendly, lots of choices, but there are no people here, you'll notice. So now my challenge is to try and get it to say people. And so this was my second attempt, and now it's got other marine animals such as whales and dolphins. So it's not really getting closer. It apologizes. When you tell it it's not getting closer, it apologizes. So it says the second most popular answer after fish is likely to be seals and sea lions. So it's not getting the goal of this at all. And then it apologizes again when I say it's still wrong. Now it wants sea turtles. And so that was still wrong. Then it tried seals. Then it tried seals again. Then it
You're asking seals. What they would say on Family Feud?
I did actually. It didn't give anything coherent. You had to explain what Family Feud was. I think that the training material for ChatGPT was more the boring Wikipedia type of text rather than the exciting, I don't know,
entertaining daily human conversation.
So it said seals 3 times because that's one word, and I was trying to get it to focus on one word. But then it said surfers and swimmers. Now it's really good because it's moving towards people. And so it got better and better. So beachgoers, and then ocean users, and then marine recreationists. Which is a word actually. You get that phrase just a couple of times on Google. I'm not sure you ever get marine-oriented individuals, but you do get marine-oriented. So it doesn't make up words very occasionally, I discovered, but it didn't actually make up any words here. But then it gets sailors. This is really good. So I tell it, you were closest with sailors, start from there. And this is the answer it gave. All right, now this may be an example of creativity. So that's the end of that. So I think we all know this is how ChatGPT works. You give it a sequence and it tries to extend it wordlet by wordlet, and it always picks the highest probability word, except when it doesn't. So there's a question: how can marine-oriented ever be a high probability word? Well, the answer is because you've already given all the higher probability words. But if you tell it to give the highest probability word, it will very quickly descend into repetition. It will just repeat itself over and over again. And so you have to have rules which prevent that. And that's the end. And now I'm hoping that we can share the screen so that we can see yours.
Shouldn't I share my screen now?
I'm going to see if I can make this. Well, Jihad will come and share your screen.
Yeah, you can. If you're on Teams,
Hi, Jihad.
click share screen.
Yeah, I clicked it. Okay, this is good.
Wait a minute. One second.
Sorry,
we need. Oh no. Gosh, I can't share my screen on. I've never found out to do it with Teams. So Barry,
Teams, can you try going incognito and loading?
No, I've tried so many times. It's a Mac computer I have.
Okay. So
I
do I
can't.
have your slides?
Someone else needs to share. I'm sorry, I didn't know we were using Teams. Someone else needs to present my presentation.
No, what you would do, I have your slides, Jobst.
Yeah, but I don't know whether you have the latest. Yeah, you should have the latest. So yeah, share them.
Okay, let's try. So
I'm sorry.
I will. It's the wrong computer. You could start by describing what you think about what I just said.
Or you made some mistakes, but we will clarify them as I go through the presentation.
Yeah, to go through the mistakes, that would be useful.
I don't remember. I think. Oh, let me see. What were they? Also, about AlphaFold, you said that it is actually modeling a logic system. It's not. AlphaFold is modeling a complex system as a logic system. So that's very important. So what AlphaFold models is a complex system behavior, the folding of proteins, but using a logic system. And it works because the logic system can approximate, I'm getting echo, to some extent what's going on in the complex system.
Okay, I have now Jobst's slides.
Are you still getting an echo?
Let me try. Now it's gone. Thank you. And then I think when you described how ChatGPT works, it was not really fully accurate. But doesn't matter. I will explain once my slides are up. I'm sorry for the inconvenience, but when I do what Teams tells me to change on my computer, it never helps. I never get the result that I should.
So I think it's under here. Down there.
While we're waiting, I was surprised to hear that the reference to Family Feud was not something that was in the training data set for ChatGPT, because
I think
the training data set is common crawl. So it's like that Peter Norvig, the father of AI, is one of the maintainers of this, and they've crawled the entire internet.
No,
it's web page data.
You're right. It's wrong that Family Feud is not in it. The reason why certain results are not given is there are several reasons. We will learn as soon as I can present my slides why certain elements of the training material. Thank you. Oh no, that's the wrong one there. That's the one with your corrections.
Okay,
No?
Jobst, we have your slides now. I will move them forward when you say next.
But you were presenting the ones with annotations and corrections. You were presenting a version where you have deleted entities. So I need to email them to you and Jihad again, the latest ones. I'm sorry for all this delay. I really wasn't prepared for this.
Okay, I made some change.
So what do you want to do?
He's sending a new set, I think.
I'm so sorry about the delay, but we are still in time according to the schedule I received from you. So
you can see our screen, right, Jobst?
Yeah, I can see everything, but
okay,
just a pain.
So will you get your email on this computer? Is he sending it to you?
First of all, I need to find Jihad's.
Yeah, go ahead.
I send it to you, Jihad, and you, Bill, and also to Barry. So
Yes.
just a second.
And let me just say one thing about Family Feud. So one thing I noticed is that a very common scenario is that it will say, either it will say error, or it will say, I don't know what you are referring to. Can you give me more information? This happened with William Hogan and with Bill Hogan. The first couple of times we couldn't find him, and I had to then add more information. Now I can't remember exactly what happened when I tried.
So I send it to you, Jihad, Barry, and Bill. I'm sorry.
Yeah, because I wonder if you
I probably
push,
didn't push hard enough.
It's in the training data set. It just needs more prompt. Maybe contextual prompting.
Barry, can you unshare this version with the corrections, please?
feedback coming from someone? Okay, I still didn't receive it, but it sometimes takes a couple of minutes. By the way,
I just start my presentation without showing any slides. It doesn't matter. So the presentation is called "Large Language Models are just very complicated analytical engines." And on the first slide, I'm showing a model of Charles Babbage analytical engine. So the analytical engine of Charles Babbage was the theoretical attempt to build an analogous computer. Can you hear me?
Yes.
An analogous computer that could perform reckoning operations like multiplication, addition, and so on. And it also has a theoretical programming language which Babbage designed, but it was never built. And I think the Royal Society of Engineering also said that it shouldn't be built because it would be useless. So then the first computer that got built was only 80 years approximately after Babbage proposed it, and I'm echoing again. Very bad. Did you receive the email now?
Yeah.
now, can you get it?
It would be really nice to get rid of the echo.
I'll mute,
So this analytical engine, I still have the echo.
okay, hold on 1 second. I'm gonna try to mute us to see if that helps.
So I try again.
Oh, so family feud.
I still have echo.
British for.
Someone in the room in the meeting can have his microphone
I remember the original most
on.
ones. The ones that most people drink us.
So, did you get the email now?
Yes, we have the email. We're just copying it to a stick.
Oh, the computer is not connected to the internet? I'm sorry.
Some of them are and some of them aren't.
I see. Anyhow, so the analytical engine of Babbage was never built. The first computer to be built was Konrad Zuse's Z3. It was also an analog computer, mechanical computer, so basically LLMs are just very complicated analytical engines. And what does it mean? So currently there's a huge hype around large language models. ChatGPT is one of them. Then Google has one which is called BARD, and there's another one by Meta, formerly known as Facebook, which is called Galactica. And so the one by the first one, OpenAI, which is also, by the way, used by Microsoft and now being built into Bing, Microsoft's hopeless competitor for Google search, is perceived as a great success and an AI breakthrough, despite the massive hallucinations that Barry has just described. And there are huge expectations from the markets. So currently, ChatGPT is valued at $30 billion. That's $30,000 million. And Microsoft is investing billions, and as I said, integrating GPT into Bing. Google Bard was also presented a couple of weeks ago in a public investor presentation, and it made a very minor mistake about the James Webb Space Telescope. And this very minor mistake basically led to a hysterical reaction of the markets. So Google lost $100 million of market capitalization. Alphabet lost $100 million market capitalization when this error was announced. And I'm still not on. And BARD will nevertheless be integrated in the Google search sooner or later. And then there's Meta, which was even launched before ChatGPT, and which was perceived by the public as a total failure due to the hallucinations. But the hallucinations were of the same degree of severity as in ChatGPT. Why then was it perceived so differently? Because Meta claimed to be able to summarize scientific papers. And so in the science domain, the inventions of the model seemed much worse than in other areas. The LLMs they all have a similar performance, but the public perception, validation of them is a matter of spin and contextualization. So this is, I think, very important. Now on the next slide, please. We see somehow the format got destroyed. Yet another, oh, I should have sent you a PDF. Anyhow. Yeah, you don't seem to have the font I'm using. Well, I'm sorry. So now the hype around large language models has also reached medicine. So on the left hand, there's a new paper which just appeared a few weeks ago, or 2 weeks ago, by Kung et al. And it tried to test ChatGPT on the US MLE, which many of you must have passed. And as you may remember, I didn't, I have the German one, but it has 3 levels, right? This is undergraduate, this seems to be before the clinical period, and this is after the clinical period. And so you see that, I mean, the paper has some weaknesses. It's not perfect, but you see that ChatGPT actually solved up to 60% of US MLE questions. And it's interesting that the performance was best for part 3, and that's because part 3 has content that of which you see a lot on the web, right? So in the internet, you have a lot of content that relates to clinical problems, but the preclinical stuff is, of course, not so much published on the web. And therefore, the performance here is the best. Now, of course, you know, the algorithm would still have failed USMLE, but it's quite impressive. And the paper concludes that ChatGPT performed at or near the passing threshold of 60% accuracy. Being the first to achieve this benchmark, this marks a notable milestone in AI maturation. Impressively, ChatGPT was able to achieve this result without specialized input from human trainers. Now then, they also claim that ChatGPT displayed comprehensible reasoning and valid clinical insights. This is total anthropomorphic nonsense, as we will see. And of course, an unrefined ChatGPT fails the exams. So I think the glass is rather half empty than half full, but the authors conclude that ChatGPT may potentially assist human learners in a medical education setting. Now, I believe that the model can be refined by training it on specific material, and then it can probably achieve 80% in all 3 parts of the exam. And at that stage, it could be used for as an expert system for decision support, but certainly not for automation, of course, because it doesn't think. So this is just to give you an impression how this is going to might affect medicine as well, though one has to put in a word of caution here. You all know that so far expert systems have been around since 50 years. Some of them have outperformed humans since at least 40 years, and still they're not seen in clinical practice very much because physicians resist their introduction. Nevertheless, it's an impressive result. So if you please could move to the next slide. So let's take a look what large language models really are. So basically, they're sequential stochastic AI models. Now, what's that? So on AI on a coaster, so basically AI is applied mathematics for the identification or mapping of recurrent patterns into machines. It's not a model of the human mind or even animal intelligence. So AI doesn't think or intend. And there are 2 types of AI. There's deterministic AI, which contains rules, search, recipes, logics, and trees, which is explainable and very reliable. So this is what's built in to most of the let's say, the last steps of the behavior of all the war and military equipment contains deterministic AI. There's also some stochastic AI built in, especially in the sensors, but the decisions are made by deterministic AI. So a cruise missile hits its target based on deterministic AI. And stochastic AI is regression classification, pattern recognition. It's not explainable, and it's probabilistic. So examples are AlphaGo and ChatGPT. And there are, of course, hybrid models. For example, ChatGPT is actually itself a hybrid model. It's not a purely stochastic model. Okay, as we will see a bit later. So if we move on, please, and thanks for moving on the slides. So what we see as AI is basically statistical learning for automation and pattern identification. Just to remind you, we have here, it's done like this. We have an input set and an output set. These are the independent variables. These are the dependent variables. Like, for example, the independent variable is an email text, and now you have as output the decision of if it's spam or not. Now what we do is we train an AI relation, and this relation is computed using an optimization function. Yeah, sorry, here's the format is broken. There was an equation inserted here. So this is just this tuple of that's used to train. So it's a training tuple for the training. And the relationship between input and output is modeled using a loss function, which is minimized by numerical optimization procedures. So that's all that's happening in supervised learning. On the next slide, we see that now they have moved on since 2013. We have moved on to unsupervised learning. So, but interestingly, the big breakthrough for the third AI wave was the Google algorithm that recognized that could create an abstract representation of a face of a cat from millions of photos. So how did this work? Millions of photos were given as input to this convolutional neural network, and it had the task to actually recreate the input that it had received as output. But while the image data was going through the neural network, and with many image data given through it, the model achieved a parameterization in the middle layer that rendered an abstract cat face. And so this is called a foundational model. So that's a model that is trained without outcome. So it's just trained by asking neural network to basically reconstitute the input it receives as output. It's also called encoder-decoder architecture. So the input data is encoded in a certain way, and then it's decoded, and then it's output again. And when you do this, you basically parameterize a multivariate distribution of the input data. And then you obtain a foundational model. And this foundational model can then also, and that's happening in an unsupervised manner. So to do this, you don't need any training data. Any outcomes. Like we showed in the previous slide, you just need the raw data. This is very practical because it saves you the whole huge annotation effort. You can just train with data, and then you obtain this multivariate distribution model of the data sequences. You can do this for images and also for texts. And then you can use supervised adaptation to get a domain model. And so GPT-3, BERT, and CLIP are three important examples for such models. Google Translate is, I think, also now moved over to foundational model, but earlier versions were still done in a supervised way. Okay, and are there any questions here? Can you still hear me all right? No questions? Okay. Jihad?
Yes, I was muted to minimize echo for you. Can you
Thank
hear
you.
us now?
Yes.
Yeah, and any questions?
I have one question. So when you talked about unsupervised learning, didn't there have to be someone at the end of the chain who was recognizing whether they had identified a cat correctly or not?
No, so because what you do when you do unsupervised learning, you basically have an algorithm that takes care of checking whether the input is equal to the output. So the model, what you do is, if you have a picture of a cat, you encode it in a three-dimensional matrix, indicating the pixel shades of gray or color. Yeah, let's say you use a black and white picture, then you just indicate for each pixel the shade of gray it has, right? And then you just measure from the output whether it looks like the input. And so you can fully automate. So of course, it's unsupervised doesn't mean that a human being is not involved. Somebody has to write all this algorithm and test it and make sure that it works. But then unsupervised means that the outcome, there is no outcome to the data, right? And so this is how foundational models get trained. And it's super impressive because without any human input into which we have used for 50 years in statistical learning, or even longer. I mean, it goes back to Boscovich, which was 1760, right? So Boscovich invented statistical learning in 1760, and for 250 years we have always used input-output tuples. And now you have a tuple-free learning. This is a huge progress. Of course, there are humans setting up the algorithm, but it's still very impressive.
I have one question. And I know that you're referring specifically to foundational language models when you refer to deep learning models being a form of stochastic models, but I just wanted to make it clear that most deep learning models are actually deterministic. The language models we're talking about, like autoregressive language models, draw from a probability distribution, for the output, and that's what makes them more stochastic, is because they're not just picking the most probable response.
Okay.
Whereas most deep learning models, like computer vision models, you serve the same input to the model 10 times, you're going to get the same response. So they are.
Okay, so they all deployed. Can you mute these again, because I'm getting terrible echo? Sorry, Jihad. Thank you. So all deployed stochastic models are always deterministic. So whenever you train a primitive linear regression or a multivariate regression or some kernel regression or classifier, the attribute stochastic refers to the way you train it. Once it is trained, it's always deterministic. So every stochastic model that gets deployed works in a deterministic fashion, that it will always produce the same output based on identical input. It's just that the term deterministic versus stochastic only describes the way, the principles which are used to create the model. But once the model is done, it has deterministic behavior. Right? So the problem that you have with why stochastic models are unreliable is that you cannot easily predict which behavior it will have based on which input. But given an exactly identical input, the output will always be the same. So the behavior of the models is always deterministic once they get deployed, no matter how they are created. Okay.
Can you then explain how it is that when I play with ChatGPT, I can ask the same question 8 times and get 8 different answers?
That's because there is a controller sitting in front of the stochastic model, and we will get back to this later. But this is basically the proof. This behavior of ChatGPT proves that it has a controller-based architecture. If it was a pure end-to-end neural network in deployed mode, it would have deterministic behavior.
I mean, one way that autoregressive language models have done that is to draw from a probability distribution. As predicting the next word, you don't just predict the most probable next word. You draw from a probability distribution, and you happen to get, a word that's not the most probable by doing that.
Let's come back to this a bit later. Okay, so can you present again, Jihad? So next slide, please. Let's look at how the large language models that have chatbots are trained. So the first step is basic training without outcome, foundational model as we've just seen it. Then there's a specification of the model to task through supervised learning. And then there's reward learning, and then there's an automated reinforcement learning approach on question-answer pairs. It's very impressive. And so the first step is in the current version of ChatGPT, or the one, let's say, about which I read publications in January, maybe they are now deployed. Another one was GPT 3.5, was used as a foundational model, and the dark blue parts are the refinement and moderation parts, steps. If we go to the next slide, we see, I have to follow this. Yeah, I think that everything came across. I'm sorry for the bad formatting. I should have sent a PDF. So in the first step, the foundation language model is trained using a transform with auto attention. So Vaswani in 2017 published, I think, since Schmidhuber published his work about the LSTM in the mid-70s, this was the next most important paper about neural networks, because the LSTMs and the gated recurrent units that had been invented by Schmidhuber and his acolytes, they were not computationally very effective. And so Vaswani et al. From Google, they showed in 2017 that you can have a purely feed-forward loop model that has only feed-forward computations, and no recursion in it, but that can still achieve the same computational properties as the recursion you have in the LSTMs. And so what you see here on top is basically just saying that a sequence of symbols is modeled as a conditioned probability, right? And so that you basically say each of the symbols or tokens out of the sequence is multiplied with the next one or the one before, given the others. So this is just really a Gaussian or Bayesian, sorry, a naive Bayes distributional approach to the modeling of the sequence. And the architecture of the model is relatively complicated, but in the end, the most important mechanism is attention. And and we will look at attention on the next slide, but because attention only uses information about other tokens from lower layers, it can be computed for all tokens in parallel, which leads to improved training performance. And so the resulting operator, so this gives you, mathematically speaking, a huge operator, which is a relation that relates a vector to another vector. You know, a function is a relation that relates a vector to a scalar, but this relates a sequence to another sequence. So it's mathematically speaking an operator. And this operator maps a sequence to itself, but contains a parametrization which models the distribution of language sequences found in the training material. This is super impressive because it basically recreate a huge distribution of language, and you see this that how good it is. You see this from the fact that it has almost no syntactic errors when it creates output. So let's look at the next slide, please. Thank you. So here you see how attention works. So this is a mechanism used in sequential neural networks to provide a context-derived weight vector that gives emphasis to prediction relevant aspects of an input sequence. So it asks here, there's an example here, the animal didn't cross the street because it was too tired. And you see that, for example, the word it receives attentional enhancement and emphasis, so that you can basically see that in this subordinate sentence, in the causal subordinate sentence, this refers to the noun phrase of the main sentence. And this is achieved by, nobody thought this through, but basically they tried it out, right? And it's done with this equation here, which basically contains the input sequence and then 3 different matrices of parameters. And if you multiply this with these matrices, which are at the beginning set at a certain initial value, then you can compute an output sequence shown here. And this is just a heuristic computation recipe, but it yields a relatively accurate syntax generation if it is applied with sufficient breadth. Breadth means that they use many such attention mechanisms on one sequence, and depths, that they stack a lot of attention on top of each other. And they just tried it out, and by doing this, they found out that this creates an autoencoding that is very syntactically very reliable. This is a super impressive achievement, but it's from the quality of the result, it's comparable to what you get with an LSTM, but it computes much faster. And so this is a very, very important result. So the final output is computed using a softmax function, which is shown here. So if we move to the next slide. So once the foundational model has been trained in this way, now comes the specification of the foundational model to the task at hand. So what they have a huge database of important questions that are often asked in the internet, like, give me a recipe for tomato soup. Can you please, where is Paris in France? Or what is Paris? When was Jesus Christ born? And so on. Questions that are often asked. And so what happens in this step is that a prompt is sampled from a prompt data set, And then, so basically, then the sampler, the labeler or annotator, as I call it, demonstrates the desired output behavior. And so in this way, they have actually written hundreds of thousands of answers to frequently asked questions. So not only have they written answers to questions, but they have also solved tasks like write me a poem, tell me a joke, write a letter, and so on and so on. And hundreds of thousands. So this was super expensive, right? So this is why OpenAI is a company that didn't do much mathematical innovation. So they just took the transformer model from Google, but then they put huge effort on this annotation. And this now they have tuples like the ones from I described at the beginning for supervised learning. And now these tuples are given to the model. And now the model is not used anymore to do autoencoding, but now it's basically like in transfer learning used to answer the questions. So it generates now a conditioned probability in the way that this is done for spam filters. And by doing this, the parameter, the millions, the 100, the 200 or 300 millions of parameters of the model gets fine-tuned because they now are changed to create the desired output, which is a very traditional form of machine learning. That's basically the Boscovich method again. Just that the loss function he was using 250 years ago was a bit simpler. It was sum of least squares. And today the loss function is more complicated, but basically it's the same trick of minimizing the difference between the desired output and the output of the model. And then that was the first step. Now you have a better model. Now then comes a step where you again collect data. So and now, but now you don't you collect questions, but now you don't write the answer anymore, but you let the model write the answers. But now an annotator ranks the answers by quality. And by doing this, a reward model is generated that tells the model, if you create this type of answer, then you get this and this reward. There again, tens of thousands of annotations are used. And now there's a really very, very important step, which was also used to train AlphaGo, which is that you use the reward model to now let the model train itself. Now you can give it tasks or ask it questions, it creates an outcome, and then you can give it a reward and do this again and again and again to make the model better and better. At the end, the model will mostly give out answers that correspond to the highly ranked answers or are like the highly ranked answers that the annotator ranked. And so this is a very important step. This method used here, this method PPO, which is called proximal policy optimization algorithm, is a super interesting innovation. And this is, I think, the biggest contribution to intellectual property or to neural network science that OpenAI has done itself. And that was already in 2017. So at the beginning, when OpenAI were just a few people, they focused on creating policy optimization algorithms for reinforcement learning. And this was, without this, you wouldn't get the results we're getting. So this step is mathematically very elegant and the decisive step that makes a difference, because here you can't get enough material. So you create kind of an artificial reward. Now the advantage is that this allows you to really reparameterize the model to give satisfying answers, but it also explains the weaknesses of the model, because it forces the model to always give an answer, and it also creates, because this is very schematic, right? These rewards are very schematic and of course not very differentiated, and that's why the model is so bland and also repetitive, because because how satisfying an answer is cannot be packaged into a reward model. But here it is done, because otherwise you cannot train the PPO algorithm, but the price is that you're getting kind of that you can recognize what the model creates, because it's very stereotypical. Okay, I hope this was understandable. Now let's move to the next slide. Oh, maybe there are questions before? Jihad? Any questions now?
Yes.
So in your picture, you have two places where a female human avatar is represented. Does that mean
I think
that there
it's
are
transgender.
Hmm?
I think it's non-gender avatar. Go on, Barry.
Does that mean that there are humans doing the labeling?
Of course, I said an annotator. So the person showing there is an annotator, and the annotator. These are thousands of annotators, a lot. They work actually. We will see in the next slide under quite strict policies, and they in the first step they really write answers. So this is a very expensive step because they have to write answers to questions, and you have to make sure that these answers are correct. So you have to have review cycles and so on. The second step, they only give ratings to the quality of the output of the model. And from these ratings, a reward model is created. This is super clever and a great achievement of OpenAI. And that's their core mathematical contribution to machine learning, is that they found a way to create, based on human scores, a reward system that is, you see in chess or Go, you have a reward system that is very simple because the games can be formulated as points. So in Go, actually, it's even simpler than in chess because in Go, in each situation on the board, you can calculate exactly how many points a move gives you. And so you can set up the reward function of the reinforcement learning to be proportional to the number of points that you are getting at each step, or at further steps, then you can have a factor that penalizes steps that are further away and so on. But basically, you have a natural way of giving points to reward system. Here, you don't have this because these are language answers, and so they have found a way to reward answer quality, and that's what the second step does. So it's super impressive. But it also explains the blendness of the question answers.
Yeah, and so this is really not supervised, but semi-supervised, right?
Well, the first two steps, the first step is called classical supervised. The second step is also supervised. It's a supervised generation of a reward model. And then the reward model is used for supervised learning, but it's then not supervised anymore. But it's basically applying a reward model that was created using supervised learning.
Okay. Any other questions, or should we move on? Okay. Go ahead, Joost.
Okay, very good. So if you could, yes, thank you. Go to the next slide. And thanks, Jihad, for your hard work on this. I'm sorry for the technical problems I have. Okay, so now this is super interesting. So there is a moderation classifier that was created to avoid non-PC language and enforce a model output corresponding to the woke cultural expectations of today's West. So we know that we have now, the culture that we have now is not comparable at all, or well, in many ways not comparable to what we had in the 1970s when the Dirty Harry movie series with Clint Eastwood was made. So now, you know, this is all outdated and everything has to be politically correct. And how did they do this? How did they achieve this? So this is a paper. I'm afraid the reference is not visible because of the formatting problems, but this is a paper called A Holistic Approach to Undesired Content Detection in the Real World. And actually on the paper, if you look at the PDF, it says warning, some content may contain racism, sexuality, or other harmful language, so that you're already warned. It's a trigger warning that you should not be afraid that some dirty words appear in the paper, as negative examples, of course. Now, what did they do? So they use basically public domain data, and then also training data, and then they have a very sophisticated way by creating a classification model that classifies undesired language. And so here you have the categories of undesired language: sex, what they call hate, violence, harassment, self-harm, and then these are subcategories. This is, for example, anti-feminist sexual language, hatred against colored people, and so on. So these are subcategories of the former. And so you see here, if you use public. So this is this shows you the area under the curve for the classifier, which is, of course, as you all know, which measures how well it performs. And you see that the specialty, so some here, self-harm has a super low detection rate, it's super bad. Sexuality is also not so good. Now they use this, what they call DAT, the domain adversarial training, where they iterate several times the training, and here fairness and bias improvements, augmentation of training data. So they do a lot of this. Was super expensive exercise. Here there's also an adversarial team built in that creates more complicated hate speech and so on. By doing this, they have already improved the baseline. Then they also have synthetic data that they have created themselves. And then if they mix the two, then they get very, very good area under the curve, as you can see here. For the broad categories, they have now not perfect, but quite good detection. Why is why are some categories not working so well? Because either they are harder to detect, or because they just couldn't put in even more effort. But this training effort created basically a PC quality classifier, and the result is so good that it is not possible to make, or hard to make, ChatGPT speak in simple toxic language. So you can, as somebody has now shown, make it say some bit toxic language. Like I think somebody made it say that the person talking should suicide herself or himself, but it can't say the N-word or FU, for example. And the classifier is probably part of the controller, and it's certainly reinforced with a deterministic filter. So it's impossible to make it say the N-word. And that can only be achieved, that can't be achieved with the stochastic model. So there must be a deterministic filter built in. On the next slide, but this was cost also, you have to also, what I failed to say or forgot to say, is that each training run to train the GPT 3.5 model costs $2 million, one run, or $1.5 million of CPU time. Even if you own all the CPUs yourself and GPUs yourself, it will cost 1.5 million. And that so that is basically the discount rate of the CPUs plus the electricity and cooling costs you have. And then the other trainings we just saw also cost millions. So I think that they have used several hundred million just for the training, plus hundreds of millions to pay for the annotator. So it's super expensive. Let's move on. Oh yeah, there's a question. Okay.
I mean, given that we're talking about PC language, I'm going to say this is more of a comment than a question, fully acknowledging that. I feel like it's giving ChatGPT too much credit to say it's nearly impossible to get simple offensive language out, because I have seen lots of examples of ways to break the prompt and get ChatGPT to go into expletive-laden tirades, and so
really?
Yeah. So that, but I think it does.
But the N-word, did you make it? Can it say N-word and fuck you?
No,
I don't think so.
I have not seen it say N-word in the vacuum. But I think you can still do a lot of harm without saying that word, right? There's a lot of other possible vocabulary you can do. I do think it plays into exactly what you're talking about, the importance of the policy. There is a policy in place that is blocking this, and being able to leverage that policy is how, because they essentially it's about coaxing the model to explicitly forget its prior directives. And if you can get it to, you can tell it to ignore prior directives as long as you can get access to the directives, and you essentially trick it into telling you the directives that are supposed to be secret. And once you know what the secret directives are, you can explicitly tell it to ignore those, which plays in exactly to what you're talking about, it being a policy, right? So that there is a direct policy about correcting vocabulary and adjusting vocabulary. So that part plays in, but I think it is giving them too much credit, saying it's really hard to do. So just,
yeah, I mean, it's how it means that depends on how you define hard, but it's obvious that I just want to make the point that they have put a lot of effort in it, but because it's a stochastic model, and because in the next slide we will, for some reasons I will explain the next slide, you can still trick it. And yeah, let's go to the next slide to understand how it can be tricked, I would say, how that works. So here you see now, it's actually not on this side, but the one thereafter, but it doesn't matter. So what results from what we just saw? So basically, the model is excellent at completing sequences from dense regions of the distributions it learned. So therefore, it has plausible answers to frequently asked questions. It can perform standard tasks quite well, but as Barry has shown us, the results need to be checked. So if we are, so to speak, in the center of the distribution of the training material, at the refinement material, it performs really well. So that's why I think also if you would now refine it using medical knowledge texts, it would become better and better. Because of the auto attention is excessively used in the training of the foundational model, and also the training data have been cleansed excessively. So they have cleansed away poor grammar. They have another a model which we will discuss in the next slide, which is used to write code, which has also been excessively cleansed. So the training data they use, they have thrown away all the syntactically poor data from poor code that to make the model perform well on coding, on writing code. And the same is true here. So they have, not only did they use a lot of auto attention, but also they have done good job at data cleaning. But we, as Barry has shown, we often get non-factual pseudo-facts, the hallucinations within plausible text, and the density of mistakes increases outside the core distribution. And the reason for this is that the model only computes sequences which correspond to the learned language distribution without understanding anything. So it's just a conditional probability it's given out. And so the answers to complex or rare topics are generic, repetitive, bland, vacuous, and anodyne. It shows a total failure in fringe and demanding areas of language, such as philosophy of science or philosophy of science, or let's say a Persian literature of the first millennium before Christ or so. It will fail, or even many other areas. The limited ability for dialogue that it has seems to be achieved by entering the previous conversation to some extent using the controller. So there's a controller in front of the model, which when you engage into a dialogue, takes dialogue history and inserts this dialogue history to the model. And this is what you can't train for. And that's the effect that you just described. I know the one who commented my previous statements. That's how you achieve what you call revealing its policy. The model doesn't reveal anything willingly. What you do is that you are but because you are now using a pattern on the sequence generator, which is what the model is, that could not be taken into account at training time, you now achieve output that cannot be predicted so well, because you can't imitate all possible dialogues at training time. And so therefore, because larger chunks of the past history of the dialogue are used as input to the system by the controller, now you get the effects that can't be predicted. And these effects depend now not anymore so much on the moderation that they've done and on all the steps they've done after the basic training, but now you get back to seeing what's in the foundational model. Yeah, and this is the reason why previous chatbots had to be shut off, because very quickly you could basically get to parts of the foundational model that were racist and full of hate speech and so on. And here you can break this protection by basically using the concatenation of previous dialogue texts as input, which is something you can't train up front. Now, but of course, the model doesn't understand answers and tasks. It generates only a chain of tokens as conditional probability. If we move to the next slide, we see another important aspect. So now are some open questions. So the first one is this an end-to-end model or a component architecture with controller? So I think it's probably the latter. The controller explains the dialogue behavior. It also explains the variance given identical inputs, and also the deterministic avoidance of negative keywords like the N-word or fuck you. So there are a couple of hundreds of prominent words that you can't get out of the model, but you can still get it to say that I should kill myself, right? But basically but this is probably happening by the controller. The variance can be achieved by two ways. It can be achieved by, of course, you can easily get a stochastic model to give a list of outputs, and then you can use a random mechanism to select not always the same but different ones. But I think here it probably works by slightly modifying the input. So the controller probably measures whether, but that's just speculation, but I think that's the most likely how I would do it. The controller checks if the input is the same as before and very slightly alters the input to select a different, to obtain a different output, or maybe it does a mixture of two so that it alters the input and also selects the second or third out of the list of possible responses, or uses another random mechanism. So that's how you get the variance. That is, of course, not typical of deployed stochastic models. Then there must be also the moderation is probably via separate module, which explains why the bot does not generate adverse texts, and why can it generate code. So OpenAI made also an LLM to generate computer code, and it was not trained on language but only on code. So by using huge open source repositories of software code. And this is probably also integrated into the whole ChatGPT architecture and sitting behind the classifier gate. So the classifier classifies that the user wants to obtain code. Then the request is passed to this codex LLM, and then codex generates the code and the controller gives it back. So this is how I think it's used. But this is just, let me say, qualified speculation out of 20 years working in software engineering myself. Now, but if you look, but still, given all what I've said, if we imagine now that these large language models are specified to certain tasks in the manner that was described for ChatGPT, they will gain a lot of usage everyday life and could also support medicine, right? I mean, and that you can create adverse language with it in reality doesn't matter at all. I mean, you just go to a construction site in your town and you listen to how the people talk, and you hear adverse language all the time. Yeah, so adverse language hurts no one. Violence is only when somebody gets physically injured. So you know, this whole hysteria about, oh, it creates adversative language. Yes, it does. But, you know, read Flaubert or Ovid or Goethe or Herman Melville. It's full of, you know, violence and adverse language. It's just part of life. And so I think this whole cult around making models not speak an adversarial language will not stop its adoption, because ultimately there's huge, these sequence generating models are super useful, and they will be put, you know, into search engines, and they will be used as, this will be the first generation of expert systems that will become widely used. And I think they're super valuable, because if you want to, you always need to look at the output carefully and judge yourself whether you want to use it. But for most, if you don't try to break the system, but if you just try to use it properly, like you say, what is the best antibiotic for a metronidazole resistant infection of the intestine, right? And now you will just get a very good answer. Of course, you can make the model give you a bad answer, you know, by engaging in a longer dialogue and so on. And then you will, because of the mechanism I just explained, you will make it create output that is bad. But basically, if you just use it in a very rational way, it will be very good. I don't know whether I still have another slide. I think that's it. Yes. So thanks a lot. And now I hope we can discuss a bit.